We're going to be looking at the wave model of light versus the particle model of light. When we look at the wave model of light, we're going to be examining interference effects. We'll be relating wavelength to interference patterns to begin with. When we have two ripple sources vibrating in phase, you can see these lines, known as nodal lines, where complete destructive interference happens. Similarly, when we have sound, when we have two loudspeakers, it's possible to find locations in the room where we also have nodal lines provided those speakers are moving in phase. We can find a nice quiet area in that room. Believe it or not, we've known that light behaves much the same way. If we're careful and we have an in-phase source, it's possible to find interference patterns in light that implies that light is a wave. So the first thing we're going to be doing is examining the path difference. So the first thing we're going to be doing is trying to relate wavelength and interference patterns that we see in water waves and comparing them to light waves to see if it behaves the same. And so we're going to be measuring distances from the source of a wave to a place on the antinode and seeing if we can relate that to the wavelength.